Right, when you're trying to solve a triangle's dimensions using the law of sines, and you're just given two sides and an angle, SSA, sometimes there can be more than one triangle. There can be a triangle that looks like this, or there could be a triangle that looks like this. In that case, right, how do you solve? How do you get both triangles? Well, the first step is to solve for the first triangle just like you normally do. So you set up your equation using a ratio, right? And you rearrange your equation, then divide by 12. And so you get sine of b equals 4.427, and b, the angle, equals 25.31. And of course, we're doing decimals because that's more realistic. Most of the times, the real world doesn't have perfect numbers. And so now, how do you get the C angle? Well, you remember this. You do 180 minus the 20 for the first, minus 25.31 for the second, and you get 134.69. Set up your equation again, right? And you get C equals 24.94. Great, so you've solved for the first one. Now what do you do? How would you go about finding it when it has a bigger angle? Well, the answer to that is that you take the 180 that you found and you subtract the 25.31 that you found for the original angle to make the new angle, which is 154.69, right? And that's your B2. That's the new angle, so you have that solved. Now you got to find C2. Okay, 180 minus the 154.69 minus the 20. Hey, pretty tiny angle, 5.31. And we put that into our ratio, and we solve for that, right? And we end up with 3.2469, or rounding 3.25. And that's an example of using law of sines to solve ambiguous case.